Welcome to today's webinar, announcing AWS Greengrass. Use AWS Lambda and AWS IoT on your devices. Our presenter today is John Turo. John is the Principal Product Manager responsible for AWS Greengrass. Today with us, we also have Nicole and Gary. They will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation while John presents. John, welcome. The floor is now yours.
And good morning, everybody. I'm John Turo. I look after Greengrass, which is our new service for IoT and Lambda execution on your real devices out there in the world. So I'll start with a joke that we love from The Office. Here's Michael Scott, who says, "We can't overestimate the value of computers. They're great for playing games and forwarding funny emails, but real business is done on paper." And it's funny because Steve Carell is brilliant, but it's also kind of profound because it's easy to imagine that this paper salesman doesn't see what's about to hit him. And for us, it's a reminder that it's very easy to get caught in our own perceptions about the world. But we're lucky as AWS because we have all of you, and with the best customers come the best problems. And so when we're building cloud services for IoT, we have to contend with the problem that all these devices out there in the world generating all this data actually can't rely 100% on the cloud. Most of the data they generate will never reach the cloud. And you can think of any number of reasons of medical equipment whose data has to be available under all circumstances, physically right there in the hospital. And industrial machinery that's so heavy it can't wait for even short round-trip latencies to make a decision, or extreme environments where the cloud, the nearest cloud data center is very far away. And as we think about this, we realize these problems are not going away even in the medium term, even as technology gets better. And what we've learned from all of you is that there are three reasons for that. We call them our three laws. The first law is the law of physics, and it says that light only travels so fast. And so you have to contend with physical distance. And if you need a very short, safety-critical or experience-critical response time in your application, even the shortest possible latency may be too long. Even if you make that latency 100x faster, it might be too long. Similarly, code can't fix broken connections. And so these are laws of physics that we expect to stay the same. Second is the law of economics, which says data has weight and it takes resources to move it around. And as the cost of storage and compute continues to drop faster than the cost of bandwidth, you start to see more data pooling on devices out there in the world. And as AWS, we try to add value to data. So for us, it's a tragedy that most of this data gets destroyed before it gets sent to a place where we can add value to it. So that's the law of economics. And finally, we talk about the laws of the land. And these can be actual laws or regulations about privacy and security and data sovereignty. But they can also be policies that a company or a factory or an organization or even a home might choose that are non-technical reasons to control where my bits go. You know, the industrial examples come to mind pretty easily, but I also think about a home OEM that makes autonomous home robots that have cameras on them. And that OEM told us that, you know, gosh, I have to do computer vision right there on my bot because this thing is driving around the house, might be in someone's kid's room. I don't want those images leaving the four walls of their house. So law of physics, law of economics, and law of the land say that processing in the cloud origin cannot be enough for IoT use cases. And we need to build on what's available in the cloud. Now, as AWS, we think about IoT in three pillars. We think about the devices themselves that are out there in the world, that can sense and act. We think about the cloud platform that ingests information from those devices and stores it and processes it. And we think about high-order intelligence that comes from processing and big data algorithms, and ultimately from the domain expertise of real human beings who use all this technology to multiply what they can do. And a year ago, we announced what we call as AWS IoT, which is our cloud platform that makes it easy for devices and cloud applications to interact. AWS IoT offers security, messaging, on-the-fly processing, and state synchronization that let devices, be they big or small, interact really nicely with the cloud. And AWS IoT also interacts really nicely with our Lambda compute platform, which provides event-driven compute functions in response to actions. And our customers have told us that Lambda is actually a killer compute model for IoT because it is event-driven and atomic in that way. And this is AWS IoT, and we're really excited about what customers have built on that in the past year and are continuing to build on it. So this year, we build on AWS IoT in the cloud with Greengrass. And you can think of Greengrass as extending AWS onto your devices out there in the world, so they can act locally on the data they generate while still taking advantage of the cloud. We'll talk about what that means, but as a mental model, you can think about the head versus the body, where the head, being a cloud, has lots and lots of storage and compute. That's where information comes from lots of devices across the fleet, across the world. But the body's also really important, and any athlete, or indeed anyone who touch types, will tell you about muscle memory and the importance of quick reactions and reflexes that are informed by experience. And so you can think of Greengrass as enabling the body to take on additional information from the head. So let's talk a bit more about what that means. With Greengrass, we extend AWS IoT and Lambda out there onto your real devices in the world. With Greengrass, you get local security that maintains the security bar of AWS IoT between local devices on the local network and indeed up to the cloud. You get a device gateway, which actually acts as a messaging broker between components of your device and between devices locally on the network. You get synchronization of device state, so you can actually track what is the last reported state and the desired future state of your devices and your applications. And last, but certainly not least, with Greengrass, you can execute Lambda functions right there on your device out there in the world. And what we've seen is this is a really powerful design pattern that works up in the cloud, and we're now letting you take that same pattern and push it down to your devices. Now, thinking back to the problems for OEMs and for enterprises that we talked about a few minutes ago, Greengrass is powerful for a few major reasons. The first is, like a body's reflex, Greengrass lets you react to local events very quickly by entirely eliminating transit latency, the time that would take a signal to round trip from your device up to the cloud and back. And however fast your connection is, 0 is lower than whatever transit time you're going to have. Along similar lines with Greengrass, you can operate your device offline, even if you lose connectivity to the cloud. Your device can continue to behave based on the data and code that it received from the cloud. A third major benefit of Greengrass is that you can program the behavior of your devices in a simplified programming model that's based on AWS Lambda and AWS IoT, using modern programming languages and modern development workflows. And now you can actually use that same programming model across cloud and device, which means you can use the same team and even some of the same code and the same architecture. The fourth major benefit we'll talk about is that with Greengrass, you can substantially reduce the cost of your IoT applications because you can process and filter data out there at the edge and send up only the most important bits to the cloud. And that can translate to pretty dramatic operational cost savings. We're pretty excited about the early response to Greengrass. And we have some partners and some customers who have already spoken a bit about how they're using Greengrass and how they're building on top of it. And you'll see even more from us in the future. One that we've spoken about quite publicly is Amazon itself. We built Greengrass into our Snowball Edge storage appliance. And if you order a Snowball Edge, you can actually use Greengrass to process the bits that are being stored in your Snowball before they ultimately get sent home. Really thrilled about what some of the partners and the customers are doing to build on top of Greengrass, and indeed to build devices that their own customers can take advantage of by putting software out in the world. So in just a minute, we'll dive into how Greengrass works, but the final umbrella point I'll make is that we tried to price Greengrass in a way that the maximum set of use cases can benefit from it. Our customers told us that in order to use Greengrass, they don't want to pay for execution on their own hardware. Gosh, if I paid for this thing, why should I have to pay you for every time I execute a Lambda function or send a message? And along similar lines, why should I have to pay for a device that's sitting inactive on a shelf or in a closet? So with Greengrass, we charge you based on active devices. Active meaning your device talks to the cloud at least once in a month. And if it doesn't because it's off or because it's entirely disconnected from the internet, you don't pay, even if your device is continuing to execute locally. And you can pay per month that the device is active. You can make an annual commitment and pay a little less for that. And every AWS account can start with 3 active devices for free for a year, and we hope that really helps people get started experimenting with Greengrass. So that's a bit about the why of Greengrass. Let's talk about what it actually is and how you can use it. Greengrass is software that you install on hardware. And the hardware can be hardware you own, or hardware you build, or hardware you buy from our partners. And it has 2 components. There's Greengrass Core, which is the primary runtime, and that's the thing that executes Lambda functions and processes messages, handles security, and persists and syncs state through device shadows. That's Greengrass Core. In addition, Greengrass Core works with our IoT device SDK so that other devices that are on the same local network can interact with Greengrass without need of interacting via the cloud. We'll talk about each of those. Greengrass Core is the software binary that goes on your device. And that's the software that is the essence of Greengrass. And that's going to contain all of your custom logic that gets deployed down from the cloud. And it is also the agent that interacts with the cloud on behalf of your devices. And Greengrass Core can pack down pretty small. We've seen it on Raspberry Pi type devices. And the recommended spec that we talk about is single CPU core running at 1 gigahertz and 128 megabytes of RAM. Today we support x86 and ARM architectures and 2 distributions of Linux, both Ubuntu and Amazon Linux. And over time you'll see more architectures and more operating systems from us. The idea is to make Greengrass fit as small as it can so it can fit into lots and lots of devices out there in the world. But we also don't confuse the floor with the ceiling. We don't see a ceiling for Greengrass Core. In fact, it can take advantage of whatever resources you throw at it in the hardware. So while these minimum specs dictate what devices can take Greengrass, we also see it running, have seen it running on heavy server appliances that can take all kinds of processing, compute, I/O, storage, and specialized peripherals. And Greengrass Core can take advantage of those extra resources and can expose them into your Lambda environment. Now, Greengrass Core works together with the IoT device SDK. And that's the existing IoT device SDK that we launched last year along with our cloud platform with an additional module that supports Greengrass. Similar to Greengrass Core, IoT device SDK fits on really big devices if you want. You can put the SDK on a server appliance. But it also packs down even smaller than Greengrass Core. Device SDK can fit on a microcontroller device as well, so long as that microcontroller device supports TLS encryption and the language of the SDK that you've chosen. The first device SDK out of the gate that we support is C++, and you're going to see a lot more from us corresponding to the full list of device SDKs that we have for our cloud platform. When you put Greengrass Core together with either operating by itself or working with any number of devices that have the device SDK, you get what we call a Greengrass group. And a Greengrass group is a collection of all the functionality that's working together on this set of devices that you defined. And when you have cloud connectivity, you can also let that Greengrass group of devices interact with the cloud. And Greengrass uses AWS IoT to maintain its long-lived connections and lets you ingest data into the rules engine. But you can also choose to interact directly with other AWS services like Kinesis or Lambda or DynamoDB. So that's a bit about what Greengrass is. Now we can talk about what are some of the features that it offers and how customers are using it. So as I mentioned, Greengrass lets you execute Lambda functions right there on your devices out there in the world. And you can't talk about why that's a big deal without first articulating why Lambda itself is a big deal. Lambdas are compute functions that are atomic. They They sit right there by themselves, independent of the server infrastructure that's required to manage them. And you invoke them with events, one time or a million times or a billion times. And our customers have told us it is powerful for IoT because IoT devices like to communicate the minimum amount of context that's necessary and have that context be added on to their events. And also, traffic from IoT devices can be unpredictable because these devices are out there in the world. And so Lambda functions don't require you to provision capacity. They don't require you to determine how many times this function will run in parallel, how many agents should be sitting there. Instead, you just trigger the function and it runs any number of times. So the same programming model can be now brought to devices with Greengrass, where I can define my device behavior as an event-driven compute function, and I can trigger that through messaging. So with Greengrass, you define Lambda functions in the cloud, and the first language we support is Python, version 2.7. And then you can deploy them down to your Greengrass Core, where they can run on behalf of the Greengrass Core itself or on behalf of other Greengrass SDK devices. And you can configure those Lambdas to get executed based on messaging, which can be triggered manually through some event in the world, or based on the clock or a calendar or a scheduler or a sensor, and also based on shadow updates that can happen through applications locally or in the cloud. And we're really excited about some of the things we've already started to see customers doing with Lambda executed locally. So one thing that, the first use case that customers have told us about is, gosh, command and control is so much easier if I can configure it with modern programming languages written in Lambda versus directly writing in embedded code. I can control the behavior of my device with a window open Lambda, and I can trigger that Lambda when I want to trigger the window to open. And that's powerful because it increases the set of developers who can program my devices, and it reduces the amount of friction that those developers have to contend with. A second related use case for local execution of Lambdas is offline operation. The fact that this code sits locally and runs on a local processor means it is not subject to the state of your connectivity. And it keeps working just fine even if connectivity drops to your house or your factory, even if your car or your truck drives through a tunnel, or even if your satellite bandwidth is really expensive and you choose not to use it for command and control. You can use this cloud-based programming language and not rely on the cloud. The third use case we'll talk about is filtering and aggregation of data. Thinking back to the early part of this webinar, devices out there in the world generate vast sums of data. You can think of a sensor which spits out 30,000 readings per second. And hard to say which of those data points are going to be valuable before you inspect them. And yet it's not practical to send those bits up to the cloud. And too often that means the data just goes untouched. And with Lambda executing locally on your device via Greengrass, you have better options. You can apply filtering and statistics that say give me one reading per second instead of 30,000 and send that to the cloud and make that a data point chosen at random by sampling or an average or some summary statistic. Send that to the cloud and drastically reduce the volume of data that my device has to send to the cloud and that I have to pay in order to transmit and store. At the same time as I'm filtering and aggregating my data, I can also apply rules on the fly, not to the summary statistics, but to the real granular data. And I can say in the cloud, I may be seeing one data point per second. But by the way, if you also see even one of the 30,000 data points per second that exceeds this threshold, I want you to also send that too. I want you to also take this local action. Sound an alarm, take another reading, turn on a fan, close the door, ask for help. And finally, the fourth category of use cases that we've seen for local Lambda is to let devices get smarter over time. When you have a simplified programming model and a modern workflow and a simplified deployment workflow that you get from Greengrass, all of a sudden it gets easier to push down new logic and to push down logic to a set of your devices and control when that logic gets invoked so you can roll it out gradually. And when you make things easier, people tend to do it more often. And that means your functionality can get incrementally better, and the devices whose behavior is determined by that will get incrementally smarter. And this just gets drastically easier and more useful than updates that are reliant on firmware updates. So that's a little bit about local Lambda and what it is and what you can do with it. Now, Lambda functions are stateless, and that's a powerful part of the model because it means that you can invoke them any number of times. Device shadows provide state for the stateless Lambda functions. And that's important because you're going to want to know if the window is open or closed. You're going to want to know what state your bulb is in before you turn it up or down. And shadows are simple. They're documents formatted in JSON that represent the last reported state and the desired future state of your devices. And they can also track the state of your Lambda functions. And these documents get defined by you. So you as a developer or the enterprise or the OEM, you can determine whether a shadow corresponds to a fleet of vehicles or one component of your vehicle, and how many there are, and how frequently they get synced. Some of that data may be only relevant to the application that's running out there in the world and does not need to be synced back to the cloud. And some of it you'd like to have the best available, last available copy of that record locally and in the cloud. And that choice is going to be up to you. So one use case that's obvious and that was sort of the inspiration for building shadows in the first place is that I can track the state of my device. And this is really useful because if I have an application that needs a REST API to interact with my device, unlock the door, track the state of my mass spectrometer that has 5 stages. Shadows present that and handle the deduping and the conflict resolution. And with a shadow, I can track the last reported state of my device and the desired future state. And I can also find out how fresh is the copy. So it's easy to write mobile apps that interact with Greengrass via device shadows. Second, I can have, with Greengrass now, an additional set of shadow documents that are never communicated up to the cloud, but track granular device state information that might be useful in a debug scenario, for example. And I can track it, and I can make it really easy to start syncing that information if I need to diagnose the device, diagnose its behavior. The third use case that we've started to see is using shadows as a lightweight configuration mechanism for the devices or for the Lambda functions. Because your Lambda functions that control devices on Greengrass can interact with the shadows, and they can adjust their behavior based on parameters set in the shadow. And this can be as simple as saying, when I flip this switch, I want the light to turn on to this level of brightness. And that can become changed without needing to even deploy down a new Lambda function. Or it can be sophisticated, where you start to use machine learning models to generate multi-factor behavior that's expressed as a Lambda function. And you can continuously update the numeric factors that drive your Lambda function and put those factors in the shadow. And you can do that, I mean continuously when I say it. You can have new numbers float down to your device more frequently than every second if you like, and leave the Lambda functions behind that intact. So that's a bit about device shadows, what they are and what they can do. Greengrass has a version of the messaging broker that we have in the cloud now applied down locally to your devices. And to speak precisely, that's a form of a pub/sub broker that uses the MQTT protocol. And the messaging broker is the train conductor that directs messages and information between Lambda functions, peripherals on your Greengrass Core, and other devices on the same local network that use the Greengrass SDK. And this works by defining subscriptions between publishers and subscribers, and a Lambda function or a peripheral or a device or a cloud endpoint can be a publisher or a subscriber. And we worked hard to make this simple so you can connect those dots really easily, but it's also quite flexible and powerful because you can use MQTT topic filter conventions to pull out parts of a data stream and process those in a custom way. We have compliance with the MQTT filtering conventions that let you do that. The final major feature I'll talk about with Greengrass is security, which you all know is very important. And what we've done is to extend the security bar of AWS IoT and apply that same bar out there in the world. So your devices and your applications interact with mutual authentication, where your Greengrass Core has to say who he is and AWS has to say who he is before they'll trust each other. And along similar lines, a device using the IoT device SDK must also present its own credentials and must also recognize the credentials of the Greengrass Core. And this is the same model that we've introduced with AWS IoT a year ago, and it's based on certificates that can be added onto your device or even flashed on in the supply chain. And secure certificates are a really powerful IoT security mechanism because they do not require sensitive data to be sent there out on the wire. Because we have Lambda functions that can do whatever it is you'd like to do running on your devices, we've now made it possible to pair your device's security certificate with the traditional signature version 4 security that other parts of AWS recognize. And this means your Lambda functions running on Greengrass can invoke any AWS service directly. And you can choose to go through AWS IoT, or you can go, as I say, directly to Lambda, to Kinesis, to DynamoDB, S3, the list goes on. And security is important with IoT as lots of other applications. And there are also challenges in making it flexible enough so it doesn't block the use cases you're trying to achieve. And we've worked quite hard to strike that balance with Greengrass. So that's a bit about why we're building Greengrass and what it does and what are some of the use cases customers use it for. And I'll just make some final points before we take questions. The first is that we really see 3 laws that determine why Greengrass is important and are going to stay the case even as technology improves over time. The first is the law of physics, which says light only travels so fast and that code can't fix a broken connection. Second is the law of economics, which says data has weight and it costs money to move it around. And not moving it will always be cheaper than moving it. And finally, law of the land, which says there are non-technical reasons why I might want to control where my bits go. And those could be actual laws or regulations. They can be security or privacy policies that a household or an organization or a business might choose. And so in order to help our customers contend with those 3 laws and still benefit from the cloud, we built Greengrass, which has 4 features: local execution of Lambda functions, local device shadows that provide state for the stateless Lambda functions, and track and synchronize the state of your devices. A local message broker, which lets you proxy data back and forth with the cloud, and also create a local distributed system that lets your local components work together. And local security that maintains the security bar of AWS out there in the physical world, but is also flexible enough to support the distributed applications that you've told us you want to build. And if you're asking yourself, why the name Greengrass? Well, what we've seen is that there are really 2 sets of developers in the world of IoT who have had to work together on different sides of the digital divide. One set of embedded developers writing code for devices out there in the world, and one set of cloud developers. And for each of these groups, the grass always seemed greener on the other side. Embedded developers have full control of the device, but they had to contend with outdated, arcane programming languages and sometimes painful deployment process and applications of firmware updates. The cloud developers have lots of great tools, but the vast majority of the data doesn't get to the cloud from these devices. And so with Greengrass, embedded developers get to program their devices with modern languages, workflows, APIs, And the cloud developers get to use all their wonderful tools and actually apply that to not 1% of the data, but 100% of the data, including data that hasn't been collected or generated yet. And you actually get a multiplier on the power of the code that you write in the cloud to run out there in the world. We've launched Greengrass in preview, which means we're trying to get folks in just as fast as we can. You can get started by signing up for our limited preview, and we're going to provide information about that, in addition to links to our documentation and more information about the product at aws.amazon.com/greengrass.